Welcome. In this video, we begin a new unit, Unit 8, Solving Equations and Other Functions. Today, we look at radical, quadratic, and factorable equations. These are just some different kinds of equations than what we've seen before. We'll look at several examples and see the techniques that we need in order to solve these problems. This is section 1.4 from the book, and we will cover the entire section. So basically, I'll do several examples for each kind of problem. You can see on the left there are radical equations, equations in quadratic form, and solving equations by factoring. All right, so we'll go through each of these three types of equations and see the kinds of techniques that we need to solve them. So to begin, radical equations. Here's an equation, the square root of x minus 1 plus 7 equals x. It is a radical equation because it has a radical in there. It has a square root. The step number one, the first step you always do when solving a radical equation is isolate the radical on the left. So I'll write this as the square root of x minus 1 equals x minus 7. I subtracted 7 from both sides. Once you do that, then you can square both sides, and when I square both sides I get x minus 1 equals x minus 7 squared. Alright, let's expand the square. X minus 1 equals, and you can use FOIL, you'll get x squared minus 14x plus 49. Now I need to combine like terms, and let's move stuff over to the right. So actually I'll write it on the left, x squared, but I imagine on the previous line, what would happen if I subtracted x from both sides? I'll end up with a minus 15x. And what if I add 1 to both sides? I get plus 50 equals 0. There we go. Now I can factor the left-hand side. This is a quadratic equation that we've seen before. Do you see how this factors? How about x minus 10 and x minus 5? So we have our solutions. X equals 10 or x equals 5. First, what happens if I try to plug 10 back into the original equation? Okay, I get the square root of 10 minus 1 plus 7 equals 10. Is that true? I get, let's see, square root of 9 plus 7 equals 10. Square root of 9 is just 3. 3 plus 7 equals 10. Ah, looks very good. So 10 is a legitimate solution to the equation. What about 5? What happens if I try to plug 5 in there? Square root of 5 minus 1 plus 7 equals 5. So the square root of 4 plus 7 equals 5. So that's 2. 2 plus 7 equals 5. Wait a second. That is clearly not true. So 5 is not a solution. It's kind of weird, right? It comes out naturally. It seems that it ought to be a solution, but when you try plugging it in at the end, it just is not. We call this an extraneous solution. Five is an extraneous solution. So the only solution to this problem is 10. It very often happens that with radical equations you end up with extraneous solutions. So it's always important to check your solutions at the end of one of these problems. All right, let's do another example. In this example, there are two radicals. Well, step one is supposed to be isolate the radical. What will I do here? Well, isolate the more complicated radical, and let's just say that we put it on the left. So we get one of these radicals by itself on one side. So how about the square root of 2x plus 3 equals 2 plus the square root of x plus 2. Now I will square both sides just like before. On the left we get 2x plus 3. On the right, what happens? That whole quantity, 2 plus the square root of x plus 2, that gets squared. All right, so let's see if you can write out all the steps. I'll kind of jump to a solution. See, if we square this, I end up with 4 plus, and then the middle two multiply together, but we get 2 of those, so that gives me 4 square root of x plus 2. And then for my rightmost term, the square root of x plus 2 gets squared. It gives me plus x plus 2 like that. Let's combine some terms. I see a 4 there and I see a 2. So I get 2x plus 3 equals 4 times the square root of x plus 2 plus x plus 6. Now, I'm at the point here where I have a single radical in my equation. Originally I had 2 radicals, and now I've reduced it to the point where I only have 1. So let's do this isolation step again. Let's isolate one of the radicals on one side. I'm going to do this. I'm going to isolate that radical together with the 4 and keep it on the right side of the equation. So I need to pull over the x, and I'll pull over the 6. So subtracting x from both sides will just leave me x on the left, and subtracting 6 from both sides makes that a minus 3. 4 times the square root of x plus 2. Now let's square both sides. X minus 3 squared equals, and on the right, when I square that, I'll get 16 times the quantity x plus 2. All right, let's expand both sides. X squared minus 6x plus 9 equals 16x plus 32. Let's move things over to the left. So x squared, so minus 6 minus 16, minus 22x, and then 9 minus 32 is minus 23, and that equals 0. So is there a way to factor that quadratic on the left? I think there is. So how about, say 23 only breaks up into 23 and 1, so I need, how about minus 23 and plus 1. So my solutions are x equals 23 or x equals negative 1. If I plug 23 into the original equation, I get the square root of 49 minus the square root of 25 equals 2. Oh, so that's interesting. So square root of 49 is 7 minus square root of 25 is 5, and that equals 2. Oh, and that looks good. Check. So this x equals 23, that is a good solution. Let's try x equals negative 1. So if I put in negative 1, I get the square root of 1 minus the square root of 1 equals 2. Oh, but on the left, that's just 1 minus 1 equals 2. No, that's not going to happen. So we have an extraneous solution. The x minus 1, x equals negative 1 is our extraneous solution. So the only real solution to this problem is x equals 23. There we go. Let's take a look at our next type of equation. This is called equations in quadratic form. Now remember, a quadratic equation is something like 5x squared minus 2x plus 1 equals 0. It's quadratic. It's a degree 2 polynomial. But this thing that I see in front of me is a degree 4 polynomial. But it's kind of like a quadratic. You could imagine that x to the 4 is really x squared squared. And then I have an x squared by itself and a minus 12. In fact, if I replace that x squared with a u, so I'm going to say let u equal x squared, this equation becomes u squared plus u minus 12 equals 0. And look at that, through the magic of this variable substitution, I now have a legitimate quadratic equation. So if I can do this, if I can take my original equation and do some kind of a variable substitution that produces a quadratic equation, then we say that my original equation was in quadratic form. Okay, well let's go ahead and solve now the quadratic equation. Does this thing factor? All right, so I get u there. And 12, let's see, that factors as 4 and 3, so I probably want a minus 3 and a plus 4. That'll give me the plus u on the inside. So I have my two solutions, u equals 3 or u equals negative 4. But don't stop here. I'm not done yet, because now I need to actually resubstitute back what the u really equals. So x squared equals 3 or x squared equals negative 4. Well, one of these right away I can see has no solution. This x squared equals negative 4. We can't do that because whenever I square something, it'll end up being 0 or positive. So the only thing I have that's actually true that works is this x squared equals 3. So I find that x equals the square root of 3 or x equals negative square root of 3. There we go. Those are our two solutions. Let's do another example. This equation is in quadratic form. Can you see what I should let u equal? Let u equal x plus 2. Then what does the equation become? When I substitute, I get u squared plus 11u minus 12 equals 0. Once again, this is a quadratic equation, and now I think we can factor it. How about, let's see, now my 12 breaks up as maybe 12 and 1 somehow, so maybe a plus 12 and a minus 1. So u equals negative 12 or u equals 1. So substituting back, I have x plus 2 equals negative 12 or x plus 2 equals 1. Oh, okay, so now I can solve these for x. In the first case, we find that x equals negative 14. And in the second case, subtract 2 from both sides, x equals negative 1. Now, these two numbers, the negative 14 and the 1, these are legitimately the solutions to the original equation. I don't really need to worry about extraneous solutions when I'm not working with square roots. So that's okay. We'll leave it here and say these are our two solutions. Now let's look at solving equations by factoring. A lot of times with quadratic equations, we will factor them to help find solutions, but there are other kinds of equations other than quadratic equations where factoring is helpful. Very often, we want to push all the symbols onto one side of the equals sign and then do our factoring. So how about this problem here? Solve x to the 4 equals 4x squared. If I push everything to the left, I get x to the 4 minus 4x squared equals 0. And now I see some common factors I can pull out. How about a factor of x squared? So x squared times x squared minus 4 equals 0. Oh, I notice I can continue factoring. This x squared minus 4, that's a difference of two squares. So x squared times x plus 2, x minus 2 equals 0. So what can x be that makes this equation true? Well, from the first factor, x squared, x could be 0, or x equals, from my second factor, negative 2, or from my third factor, x equals 2. So those are the three solutions to my problem. We could say the solution set is the set containing 0, negative 2, and positive 2. All right, last question. Solve x cubed minus x squared minus 4x plus 4 equals 0. Well, in the previous problem, there were some common factors I could pull out. I don't see any common factors among these four terms. So, any thoughts on what I could do? Yes, it's our old friend, factor by grouping. Let's see what happens here. If I group the first two, x cubed minus x minus, and I'll group the second two. Now be so careful. I need 4x minus 4. Do you see, by grouping and by having a negative sign out front, That's why I need to make sure I have the negative sign in the middle so that the negative times the negative gives me the positive in there. Okay, this whole thing equals 0. Now I factor what I can from the first pair of terms, and I factor what I can from the second pair of terms. So from the first, I can pull out an x, I think. X times x squared minus 1. Oops, I see this should have been x squared up there. There we go. That'll work out better. How about if I make that so I can pull out an x squared? X squared times x minus 1 minus, and what can I pull out there? I can pull out a 4. X minus 1. Oh, I like to see that. I see x minus 1 equals 0. So that tells me that I can make my x squared minus 4 a factor on the left, and x minus 1 a factor on the right, and that equals 0. Am I done? Is there more factoring I can do? There's a little bit more factoring. Here on the left I have a difference of 2 squares, so this factors further. X plus 2, x minus 2, x minus 1 equals 0. And here we go. I'm at the point now where I can read off my 3 solutions. X equals negative 2, 2, or 1. So my solution set, negative 2, 2, and 1. Alright, so that is our quick tour through 3 different kinds of equations we might see. We'll do some more practice in class, but until then, if you have any questions, please let me know.